Hello. We should be back live. Gotta love hard crashes, man. I ran the sim and it instantly just my whole machine just locked up. It's bizarre. Very bizarre. Okay, well, this does work, so that's cool. Sure, the Twitch category is totally wrong again, and there's just too much stuff. Too much stuff that just screws up for no reason. There we go. Well, we'll hope that that stays more stable. What can I do? I'm streaming on my laptop, right? Speaking of which, I should order a new desktop to California, so I have one to stream there. Okay, so multiply by RNG. If we go to drone race, yes, this is a knitting with 0.1 F randomization, right? And so far with 0.1 randomization, it actually just kind of works. Can I like just crank this thing up a ton? What happens with 50%? Okay, so it misses. It doesn't confirm that it's hit the targets with 0.5. I'm kind of interested if we train with this. I'm going to try to train locally. If it locks up my machine, we'll just do all training remote. What I do here? Just the binding file, right? Oh yeah, the config. Chat's hopefully not broken as well. Looks fine. I did put my windows in the wrong order. All right. Okay, error drone race. Ah. Okay, we're training. So the question is going to be whether this achieves the same success rate now. Hey Sam, welcome back. Hopefully we do not keep crashing. I probably should just put this on the remote puffer box. I think I'll do that next. Okay, interestingly, we're stuck at like 0.75-ish. In the new one. You sorted it anyways? Cool. So this is like super heavily randomized. This is definitely better than the model that we trained before, even if it doesn't have 100% success rate. Yeah, like some of those are, like you can tell that didn't control well at all. Yeah, so I mean, this is crazy randomization. Like, gravity can be 50% higher or 50% lower, for example. Might have to resweep hypers, might need a bigger network, might need to make it. I don't know if we should let it observe the coefficients, honestly. I honestly, like, it'll probably do better if we let it observe its coefficients, but, like, you're not going to be able to observe the coefficients correctly on the real end. So it's probably better to not let it. Yeah, you can see sometimes it's like super agile, and sometimes it's super sluggish. So I mean, pretty much if this doesn't work on a real drone, it just means like we didn't randomize a variable that's relevant, or we didn't account for a force at all. Like what this essentially prevents you from doing, right? This prevents it from being like, oh, the mass wasn't exactly the same, or you know, like, oh, the forces, like the moment of inertia is different. Like it doesn't really matter because we just train on everything. Honestly, point like 0.5 is pretty aggressive. Like this thing can barely fly, say. If I just do 0.25, it might just work out of the box. Like, let's see if it works with this. Because I think we'll just be able to estimate everything to within 25%. Ten to 15%, yeah. The one thing I do kind of want to mess with, so let's do this first, and then I think we're going to have to mess with dt, right? Like the delta time is going to change per step. How big is our dt right now? That's too small, isn't it? If this is in seconds, it's 0.02. Yeah, so this controls way better here. Like 93%. And this should still have enough randomization in it. Yeah, you can see how screwy this drone is controlling in here. You can see it's like super screwy controls, right? Yeah, that's very different here. It's like way smoother. It's got like more inertia to it. What happens if I make this like, if I make this 0.1, does it break? So this would be like 100 ms latency. Or not really latency, but 100 ms precision, which would be very bad control. Yeah, so this doesn't do anything like this, because it wasn't trained to. Let's see if it can actually train at 100 ms. Oh, it's having a tough time. No, it's actually picking up. Huh. Number to hit is 93%. Oh yeah, this is completely fine. So yeah, pretty much scratch that, guys. Like any control frequency you get should kind of be okay. Actually, this literally does better. You technically make the reinforcement learning problem easier when you do shorter horizons. It's not super surprising. This doesn't look good though, right? It's like kind of flipping all over the place. We originally had some DTs that would get good and then fall off a cliff. Well, you can see here I have it flying with a DT of 0.1. It's flying very weirdly though. What do you think is realistically the most control lag that we would have to deal with, like 50 ms? We should be able to get 20 hertz control, right? Yeah, let's get like a 20 hertz controller in here. And we'll see how this does. Because like this is solving, but I don't know if it's stable. Because it's kind of like spinning like crazy. I don't know. I mean, realistically, it is actually possible that this thing just learns to fly a drone in the craziest way imaginable, but it still works, right? It wouldn't be the first time RL does that. 50 hertz could be reasonable. Well, we can definitely solve it with 50 hertz. Let me see if I can solve it with 20 and get something that looks like decent. Because if it solves at 20, then it'll solve at 50. If it doesn't look reasonable, we'll go down to, the other value. What are you doing RL on? Give me 7 seconds and you will see. During your undergrad, would you prefer college over branch? What is branch in this context? What do you mean by branch? Okay, we need to slow this down so we can actually see if it's flying reasonably. Oops. Cooking a Rocket League AI. It's a drone. Not that far off. Branches like. What do you mean prefer college over branch though? Like, in the US at least, the way it works, it depends on the university. Some universities you apply directly to a specific major. Some universities you just apply to the university and then you pick your major, like ideally by the end of your freshman year you kind of know what you're doing. I don't think that this looks too bad, Finn. What do you think? It's like there are super fiddly settings where it doesn't look like smooth like this, but that's kind of a good thing. We always apply to do a specific degree, really. That kind of sucks, honestly. So like at Stanford, you apply just to the school, you can pick your major, and then there are no enrollment caps. At least in CS, there were no enrollment caps. And you could take whatever course you want in whatever department as well. Yeah, this is kind of good because you can see that there are definitely smooth problems in here. Not just from Eng, but there are unusual options. Insufficient freedom. Insufficient freedom. Not enough bullets per eagle. Uh, Rand F. RNDF. Is there anything else we need to randomize? Like, do you think we need to actually randomize the physics calculations themselves? Not really, right? Like, the physics formulas. I think that the physics are what the physics are, and if anything, we should model. If we have a specific type of noise to model, we should model it directly. We'll see how this goes. So this is now if there's a bit of deviation in the amount of time that a step actually takes, which is very likely, right? Like the instructions are not going to come in at a constant rate. Yeah, see, this is taking a couple points of accuracy off of it. Which is fine. Sure. Back shortly. Yep. This looks fairly good to me. Like this definitely has more realistic and less realistic portions of it. Now I would actually like it to be, I would actually kind of like to have less aggressive randomization in some areas and more aggressive randomization in others. Like, can we get this to fly big drones and small drones, for instance? Big drone, small drone. So we have thrust coefficient. Kilogram meters squared. Angular damping coefficient. Linear drag coefficient. So I would basically like to have this, I'd like to have a formula that can produce any reasonable drone. Does that make sense? Screw it, let's just stick it into Grok. Let's see if I can get it to do this. And I'll check the physics with Salmon Fin afterwards. Work by Jeff. And Aaron, of course. Okay. So you scale the mass with size cubed. You scale arm length linearly with size. Scale with mass times arm length squared. Okay, so this is what I was looking for. Scale with mass. Angular damping scales with inertia. Perfect. This is exactly what I wanted. You guys see the point here? Like, we're going to randomize everything, but we're going to randomize it within somewhat realistic ranges. So we consider, like, all possible big drones, all possible small drones. And if we do this correctly, this will be able to fly any drone. And just zero shot. Of course, we have to get all the physics right and stuff, but maybe we don't randomize gravity as well. Who knows? We'll see on that. I'm going to use the restroom real quick. I will be... Let's see how I mute this thing, and I will be right back in a second to get a drink as well. And then we'll implement this. All right. That's exactly what we needed. Put this on the other screen, and we'll start implementing it. Do we want to do it off of mass, size? We would like to have a base parameter, which I guess would probably make sense to have be size. And we'll have to like fit some coefficients. Size. And float domain randomization. So we've got arm length. Is there any other size? Just arm length. So rotors according to thrust. So this is going to be in Drone Lab. We'll just have to read the physics. So move drone. So you get the thrust. Okay, so it is, the arm length is basically the radius here, right? Yeah, the arm length is basically the radius. So why don't we go try to fit our own drone, I guess? And we will scale it up from there, maybe. Air 65 drone specs. This thing weighs nothing. It's 17 grams. $65 millimeters. Wheelbase. What's the wheelbase size? Does that make sense? Drone wheelbase. Quadcopter frame. It's the diagonal motor to motor distance in millimeters. Okay. So we'll just like We'll just fit some stuff to this anyways. So size cubed times the RNG. Oh yeah, and the RNG is... It should probably be per component now, right? Which will make it harder. Inertia scales... Hang on. Mass scales with size cubed. So arm length should just be size over 2, right? And the IX is... This scales with mass times arm length squared. Is that just a fifth power? That would seem weird to me. I don't want to have multiple sources of randomness like this, do I? No, I guess I kind of do. We'll try it like this first. Divide by base. Base I. Okay, so this is the base inertia. The hope here is that we'll be able to like slim down the RNG requirements. So we won't have like crazy things that can't fly, but we'll have like a lot of different drones. Should be better. Like a lot of different actually possible drones. Oh, it's actually, wait, base. I don't need to divide by this, do I? Okay, hang on. Let's get the rest of these done first. So thrust coefficient should scale with mass. Oh, I see. So this is divided by this times. Oops, this is parameters mass, base mass. It's the RNG. Angular damping scales with inertia. Base. So angular damping is going to be this base. All right. And drag should scale with size. We can let gravity be what it's going to be for now. That is exact. Velocity. Actually, we'll give it a 1%er just because it doesn't make a difference, I'm sure, but we'll do it anyways. Max velocity and omega scale with size and mass. They scale with the motor thrust as well, don't they? Wait. Inversely proportional to size. That's not true, right? The max RPM is determined by the motors. So that's Frock being stupid. If anything, you would want to have speed should be directly proportional to thrust, yeah? Wait, but why is there a max RPM anyways? Let's just go study the physics a little bit here. Okay, so these are thrusts, right? Motor thrusts. Drone K thrust. Oh, you probably don't need this RPM thing. I'm gonna ask Finn and Sam if you need a max RPM thing. I think you can probably just model this as thrust, right? I believe you can. Let's just do this. And then likewise, is the maximum velocity also not modeled by this? Yeah, so the maximums should be modeled perfectly by the physics, I believe. Assuming you have the drag, which is proportional to your velocity, that's going to create a maximum, isn't it? That's going to create a maximum. Cool. So all I have to do is fix this this total mess that I have here, and we should be able to get a nicely scaled drone randomizer. And we'll actually be able to visually see this too once it's done. That like we'll be able to visually see that we have larger drones, smaller drones. So we give it the size. Size is going to be divide a factor of 2. Mass scale. Okay, so this is going to be scales. So mass scales cubic with arm length. Another word to do this is m proportional x cubed. And then we do I proportional to mx squared. So we just do float scale. So you do arm length squared, thrown mass, so we do I scale. My x is going to be scale, scale, scale. I don't feel great about having the inertia moments being so screwy, but it's fine. We'll let them. We'll let Sam and Finn take a look at whether this modeling makes any sense. And then the thrust really isn't proportional to much of anything, right? Do we just assume it's proportional to mass? I'm going to assume it's proportional to mass, and then I'll double check. Okay. Angular damping. Angular damping scales with inertia. Base average. Okay, so this is good. And then just drag. No, drag scales differently. What is the drag formula? What's linear drag scale with? Isn't it just negative b v? Yeah, it's just velocity. It doesn't scale with mass. Rock is stupid. Well, it depends how they've done it. Let me just double check their formula. No, they've done it correctly. They've got b and v. Yeah, it's multiplied by velocity. So it's just proportional to velocity. Oh yeah, so this is But this is just the coefficient. So this doesn't get multiplied by anything. The coefficient is just the coefficient. Isn't it proportional? Wait. Is it not proportional to size? It should be proportional to the area, right? Which is size squared. How do you model that? Do we say it's proportional to size squared? And then they have this clamping term, these clamping terms. Which we will see what happens without these. All right, so all we have to do now, we should have the proportionalities right. We just have to make sure the constants aren't crazy. But they shouldn't be, though. Because base size we're going to do everything from, say, 0.01 is, that's a centimeter. We don't need to do a centimeter drone. 5 centimeter drone. Yeah, we'll do like 5 centimeters up to a meter, I guess. This is in meters, right? Actually, a meter's not going to fit through the rings. That's kind of awkward. We'll have to figure that out as well. Oh, I did this twice by mistake. max RPM. Okay. Yeah, this is at Nan, which is really cool. Headphones ain't working, so I can't hear you. Can you reply in the chat? Yes. Okay, so we just have to figure out basically where we've named some things, and we'll be fine. Let's go to DroneLib. Whoops. Okay, so this is where the drone is apparently. It's hard to see, but that is a quadcopter. It's like a big quadcopter. Cool. We have negative NAM already. And this is on line 404. Oops. Of drone race, which is intensity. I see, the max RPM. Plus 1 times 0.5. We're just going to do like this, I guess. Let me go see what that is at the door. All right. Back to work. So, stream is not dead, right? We're good? Yeah, we're good. There's an electricity blip. Rings the doorbell. Okay, we still have NANDs on 404, which is intensity. Yeah, that shouldn't be able to be NAND. Why are you using Grok 3 over Gemini, GPT, or Claude? Because all the labs just leapfrog each other like every few months anyways. There's really not a huge point to just switching back and forth between the models. Like for what I like the stuff with the stuff I'm doing, they're all equally bad. If I wanted to use a better model, for instance, and have it take longer, I could literally switch to Grok 4, since, to my point, the labs leapfrog each other every few months, and at least as far as they claim now, Grok 4 is apparently the best. Gemini CLI. I don't really want any of the models touching any of my code at all, honestly. The only thing I use that touches any of the code, if you've kind of noticed, is I have this autocomplete like this. This is like mostly single line autocomplete Super Maven. And I really like this one because it's a dumb model that basically syntax fills, but it's really, really fast. Right? Like it's instantaneous. I don't like copy pasting everything. Well, I'm not really copy pasting that much, as you can see. Like honestly, if I had to choose to keep one, like Super Maven or the bigger models, right? And if I could only use one, it would just be Super Maven for the typing buff. It's more important than anything else. I mean, arguably the other models, like for looking up documentation, are nice, but it depends what I'm working on. Okay, so here we're at the breakpoint. Density is 0.5. Okay, so we get NANDs into this thing now with the new formula somehow. Oh, it's because of this. Duh, right here. Oh, I see. So, okay, it does make sense to use RPM then, I guess. I see. So I'm wrong here. It actually does make sense to use max RPM because it's like quadratic, and apparently that's the thing you're setting is the RPM directly, not the torques. So we'll restore this. Let's do something. If the last person here in the chat is not a bot, please type potato. I'm getting bot vibes from the first message. Do we just make max RPM scale with like square root of size or something? No. Do we just make it scale with size? Well, let's just guess something for now. We'll do size squared. All right. So this gives us RPM. And we're still getting undefined behavior. Okay, this is a nan. Because RPM is nan. Because the action is a nan. How'd nan get into actions? Something blew up. Oops. Okay, we do get nans. It's probably like max velocity going infinite or something, right? Let's just put max velocity back on for now. We'll just do like this for now, yeah. And we'll just like keep it, let's say we'll just like keep it for stability. Okay, so they're crazy drones in this space, and then they're like reasonable drones in this space, yeah? We should also make the rings, change the rings a little bit. What? Why does this take void? I didn't even know you could do that. That's weird. We have to do a few small things, I think, with this. Do it like this. The drone up top. Float ring. This equals 2 times. Okay, so it's going to double the drone arm length. And then this is going to be ring radius. And then this is going to be ring radius. So this is not working. Let me get rid of this bot real quick. Obvious bot is obvious. Here we are. Hey Erin, how's it going? We're doing some drone stuff at the moment. Clearly have some bugs, but what we're doing is we're training all sorts of different sizes and weights and stuff of drones. Visual arm length. Little tricky. Little tricky. I mean, there's several things we could have messed up here, right? Easiest thing I can do at this point would be just go size. So we'll just do it drone 2F. So this should give me a non-randomized drone. Yeah, so this is reasonable. This ring is completely a weird size. Let's do this. Yes, this arm length is not remotely correct. It's rendering the drone the wrong scale, basically. So the box is 10 meters by 10 meters at the moment. I think that's like a reasonable initial size for this. Actually, I don't know if the fast drones or the small drones are, the small drones or the large drones are faster. I guess when Finn and Sam are back, we'll ask them. Love the work you're doing on drones. Started listening to your thesis, and I'm trying to understand the neural net. Not forgotten about Ken and RL discussion, just busy finding a job. Yeah, it's rough. I mean, this is really, like, low-level material stuff is pretty close to the top of the list for things I really want to do. It's a bit harder. Like, I think that the most likely thing that's going to happen, so drones are considered low fidelity control because they're really not that many degrees of freedom. I think that what's likely going to happen with Puffer is we're going to find, like, financially, we're going to find a big contract in either logistics or low fidelity control, because this is what we're really good at doing now. And the hope is that we can eventually do like material sim, but that doesn't mean we can't spend any time like looking into what's feasible in material sim now, right? And I'd really like to do that, because if there is something that's actually super feasible, we can just do it. If it's the type of thing that we need to scale up to, then at least we'd like to know now, like the type of things that we will need to scale for and build around it. The neural nets are really simple, Arim. Like, the neural net architectures are not that complicated that we use. It's mostly about the environment in the data and then just making everything really fast. It's like the biggest thing with RL. What if we do this? Is the drone just smaller now? Oh yeah, the drone's tiny now, yeah. Definitely update you on the material sim in 2 weeks at most. I mean, we definitely want to do stuff in that space. Here, let's put it this way as well, right? So, if you find something that we can simulate, that will actually like do something useful, and basically any materials, there's chem space, uh, and there's actually like, you know, contract opportunities that come out of that, we will bring you in on that. So this is pretty much the way that it works with all the open source stuff, right? Is that like everything's kind of out in the open for the most part. But like if you have knowledge of another area that creates opportunities for us to throw our tech on a new area, then we're absolutely interested in bringing people in on that. It's just that we do it via contracts instead of via hiring because it's a lot more guaranteed for everyone around that way. Where the heck is the body? Oh. Okay, there's our drone back. It's just tiny. Let me show you the Discord channel. Discuss the papers. Let's find this version. Yeah, that's fine. You can do that. Should be good to hear. It's just that the drone is tiny, yeah? If the drone is this big, how big do we make the hoop? Is that a big enough hoop? Yeah, I think that this is good. And it's still zippy. It's just being rendered at the correct scale now. Oh, and the rings are like harder. Okay, let's do the randomizations now. What happens if I do 0.5? Ah, so we can see that basically immediately from this, right? The scaling formulas are wrong. Because all I did was make the drone bigger, and now it doesn't control right. So we got to figure out what I did wrong with that. Okay, so if I make it scale here with X, this is slightly better, right? And I should be able to train something on this. There you go. Let me go join that. Is this a new DM or something? Where did you send this to me? Do you put it in Puffer or something? Where'd you send it? So this trains. Oops. It's pretty zippy, but it trains, right? Sent on Puffer previously. Did you receive the link to the channel? No. Did you DM it to me? Wait. I don't see any new message requests. Like, where did you stick the link? Just stick it on the like stick the invite link on the Discord or something, or DM it to me on Discord if you want. Because if you're putting it in the chat, like the chat's not going to post links. YouTube doesn't like links. What is this detaching after fork? What? Okay, something weird happened. Okay, so this breaks. So loops infinitely is kind of funny. It's probably just not able to find a spot for the ring. Oh yeah, because the rings are going to be huge, right? A 1 meter drone. You realize, like, I have open DMs, right? Cool, joined. Oh, you made like a full Discord for this thing. Your Discord is like default no permissions on everything by default. So I joined it, but I can't see anything. Ridiculous.